Welcome to one last night of triangles. Tonight we're going to talk about isosceles and equilateral triangles. No proofs tonight, guys. We're just going to work on a little bit of, kind of closing up the triangle stuff. We've been neglecting these guys. They're special. They get their own night. So here we go. We're going to go ahead and start off with our isosceles triangles. We know isosceles triangles. They're the ones that have the two congruent sides. Normally, you see the two congruent sides on the side, and it's not on its side like this. So here you see the two tick marks as your two congruent sides. Normally have it sitting on the bottom, but it doesn't really matter. What we're going to do tonight is talk about the different special parts of our isosceles triangles. They have special names, and we're going to use those special names to talk about some relationships. So our first one we have is what's called the vertex angle, and that's just simply the angle that is ordinarily at the top, but it's the one that's formed by your two congruent sides. It's got the two congruent sides, and the little tick marks there is the two that are forming it. So that's your vertex angle, angle 3 in our case. Then we have the congruent sides themselves. Those congruent sides are referred to as legs. There are two of them because there are two congruent sides. They're legs. And then we have what are called the base angles. The two angles that in our case, 1 and 2, they're the ones that are not the vertex angle. They're the other two angles. The ones that are ordinarily right along the bottom, because most people, when they draw an isosceles triangle, put that non-congruent side as the base. So we're just going to refer to those as base angles. So, isosceles triangle theorem. The isosceles triangle theorem just says something that most of us already know, and I think a couple of us have actually been using this in class a little bit. The isosceles triangle theorem says that if we have an isosceles triangle, or as it says here, if two sides of a triangle are congruent, giving us an isosceles one, then the angles opposite from those sides, or the base angles, in our case, that's their special name for them, the base angles are congruent. So you look, our legs are AB and AC, and therefore the base angles, angle B and angle C, are congruent to each other. Okay, going along with this, we have the converse of that. So as you guys recall, converse is just when we switch it around. So the original one was if the triangle's isosceles, then the base angles are congruent. Here it's if the base angles are congruent, then the triangles are isosceles. The book kind of words it a little differently here. Not quite the perfect converse, but you get the idea. It's basically the other way around. This time we have two angles in the triangle that are congruent. If we got the two angles congruent, then the sides opposite from them become our legs of an isosceles triangle. So we have if the sides and the angles, and now we got if the angles, then the sides. Let's do an example of this. Let's see what we can use. Isosceles example. So we got a isosceles triangle here. We know it's isosceles because we got the legs AC and AB. It's even sitting on the base for you, not even turned on its side. It's sitting straight upright. So the first thing we know is that since it is isosceles, our theorem tells us that we have two base angles that are congruent. So angle B and angle C, let's mark those congruent there. B is congruent to C. So if they're the same, I know B is x degrees, so C should be, that's right, x degrees. It's exactly the same. B was the x, so C is the x as well. So now we've got an isosceles triangle. We know it's a triangle, so that means 180 degrees, right? So we got x degrees, 38 at the top, set up a nice little equation, x plus 38 gives me 180. Well, simplify that a little bit. I got x plus x. I know that's just 2x plus 38 equals 180. Keep going with the algebra and subtract my 38 from both sides to get the two x's by themselves. And then I just divide by 2 to get x is 71. So now I have 71 degrees as my x, and as you can see, B and C, since they're both x, they're both going to be 71 degrees. And that'll give me 180 degrees total in the triangle. Moving on. We've talked about isosceles triangles. Let's talk about equilateral triangles. We have these two terms we threw out at the very beginning of the chapter. Hopefully you guys had heard of them before. We got equilateral on the left and equiangular on the right. Equilateral talking about the sides being congruent, the equiangular being the angles are congruent. We have these two corollaries. A corollary is just something that follows the theorem. It's just a logical next step. We know that if it's equilateral, you guys probably already know that all the angles would be 60 degrees. Well, if they're all 60 degrees, then we know they're all equal, right? So basically what we're going to say here is that if it's equilateral, then we know it's also equiangular. If equilateral, then also equiangular. And this works the other way around too. We can say if it's equiangular, then it's equilateral. So we just know that those are kind of, interchangeable, joined at the hip, if you will, terms that you cannot separate from each other. If it's one, then it is the other one as well. Always, always, always. Equilateral, equiangular go together for triangles, at least. So let's do an example with these equilateral, equiangular triangle things. Here's a triangle. We know it's equilateral because we've got 3 tick marks, AB, AC, BC. All of them got those little red tick marks on my picture there. I see that I have angle C labeled as 3x plus 15. Well, it's an equilateral triangle. We know all the angles are the same. They're all 60. That sounds like a pretty simple equation to set up. I know 3x plus 15 is going to give me 60. All right, well, let's go ahead and start solving it. I know I can subtract 15 from both sides. Gives me 3x is 45. Then I'm going to divide both sides by 3 and get x is 15. So it looks like I'm done. I got x is 15 degrees. I'm just going to do a quick little double check just to make sure, because that seems really too easy to be true. So let's go ahead and plug it in. X is 15, so I got 3x plus 15. Plug it in right there. 3 times 15 plus 15 equals 60. Now this should be true, so let's keep going. 3 times 15 is 45. 45 and 15 gives me 60. There we go. Smiley face. Happy. Good to go. Equiangular triangles and equilateral triangles are the same thing. Isosceles triangles, 2 sides and 2 angles congruent, and they're across from each other, the sides and the angles. Hope you guys enjoyed. See you guys tomorrow.